Hi, my name is Stefan Kaler, and today we're going to talk about the most important aspect of your data warehouse, which is profiling your raw data correctly. Before we dive in, first let's define what raw data actually is. Raw data is the unaltered data from an upstream or external data producer. It is the most fundamental source of truth in your data and forms the building blocks for all your downstream logic and insights. Typically, agents shouldn't derive insights directly from raw data because it contains flaws, and building them from raw data is less efficient than deriving them from a downstream table. But since all downstream tables are built from raw data, and the agent might want to create a refined table from this data, it's vital that the agent has a good understanding of what's happening here. As you can imagine, there's a lot to cover in this video, so without further ado, let's dive right in. Ideally, you know what data in your warehouse is raw. If you don't, please watch one of the prior videos that I posted on warehouse lineage. So where does raw data come from? There are a variety of sources. It can be generated by your immediate department. Say you're on a data team that analyzes user engagement patterns with your segment of the product. You might be ingesting raw data from sections of the app that your department is responsible for. This telemetry data is coded out by engineers in your department. Through your interactions with these engineers, you typically have some influence over this data. Data can also come from external sources, such as data shares, where data from other departments is hosted. Data can come from external sources to your company, such as APIs, or data downloaded as part of a one-time deal, which is then stored internally. In each of these scenarios, your control and influence over the data that's being provided to you from upstream decreases substantially. While you likely have influence over data generated within your department, data from external sources, even within your company, can be difficult to influence. Data generated outside of your company is even more difficult to influence because unless you're paying the source a lot of money for that data. And even then, you might be able to have a conversation with them that yields some results, but it's going to be difficult to get them to change their data. So this is why defensive coding is so common in a data warehouse. You might control one sliver of the data that's coming to you, but you only have some influence over most of the data. Data will come to you in all different shapes and sizes. So you'll need to build mechanisms to coerce the data into a standard format and catch situations when the data suddenly changes for seemingly no reason. I'm not going to go deeply into ingestion mechanics because it can cover multiple books, but it's really important for your AI to know the mechanics of how these processes work in relation to your warehouse, since it can cause a lot of nuance in the data. One key thing to know is what kind of load job is pipelining data into your warehouse. Data could be coming in via a full copy job where entire data sets are copied on a daily basis. This is very easy for you and the AI to understand, but it's also extremely inefficient and will cost you a ton of money. Each copy takes compute, and if the data you're copying grows each day incrementally, so does the compute you'll need to process it. I've seen teams do this with transformations downstream in the data warehouse, and it can be disastrous, resulting in analysis being many days late, plus incredibly high cloud costs. What many teams like to do to improve efficiency is incremental copying, as shown down here, where chunks of data are copied over in batches as they're ready. So day one is complete, that data is in staging, and is then copied, pipelined over into the warehouse, and so on and so forth, and the data sort of stacks on top of each other. This is fairly efficient because you're not unnecessarily transforming data. Usually most companies will have a little bit of overlap between them so that you can catch any late data points that are coming in. But this is something for your AI to take into account, because what if you don't have a very large buffer and a late data point comes in? Your AI might not get the full view when making a calculation. Did I skip a slide? Another ingestion pattern to be aware of is streaming data, where individual events are copied into the target as they become available in real time. Why doesn't everyone just do this? Because it's difficult and it's expensive. But if this is what you're doing, it's important for the AI to know. Imagine you're streaming data into your warehouse and you ask the AI to create a metric with the total number of users by day. Well, today isn't done yet, but the system will see data for today, so you'll only get a partial count in your metrics of today's usage. If you give the AI this context, you can factor that in so you don't need to go back and correct it, maybe taking out the calculation for today. There are many issues that can occur during the ingestion process. Duplicate rows, late data, changing data, backfills, all this stuff can cause hiccups downstream. You can mitigate them by using primary keys. I'm not going to go in depth on what a primary key is, but because I have limited time, but it's important that you use them and your AI knows that you are using them. One last thing before we move on to the next section. The ingestion process, or the raw layer, is the best place to apply personal information and compliance controls to your data, since it's the earliest step in your data process. If it happens later, your data might have proliferated through your warehouse, making these processes more expensive. Once again, that's a topic for another video. When you ingest raw data, it can also be a great opportunity to enrich it with a few key columns that can help provide a signal to you, the user, as well as your AI. Some columns I like to add are when the data is loaded at. This can be useful for debugging pipelines and for understanding whether there's a delay in the data. The source of the data. This can be incredibly useful if there's an outage, as it allows you to quickly chase after the upstream provider. It can also help with attribution if you run into that problem. Batch ID, if you're running batch jobs, this can tell you which job that row came from, and if there's a problem with the batch, you can easily track down the associated rows and perform targeted deletions or edits to the data. Understanding your existing raw data can be very overwhelming, especially if you don't have good data documentation, which unfortunately, as we all know, is often the case. In this section, we're going to go over 2 techniques for understanding raw data when you don't have that documentation. The first technique is to create a data hierarchy. A data hierarchy is a mapping of core IDs, their granularity, their relationships to one another, and how they relate to your business use case. In a data hierarchy, we start with the most granular ID and work our way up to the least granular. Every step of the hierarchical chain has fewer unique IDs than the previous step because it represents a broader concept. For example, a common use case is tracking user engagement within an application. The application is simple. A user logs in, taps or clicks around, and the application responds. The most granular thing happening here is all the back-end processes the application runs to cater to the user, since there can be multiple of these that map back to a single user action. The next step up the granularity ladder is the user action. There can be multiple of these in a session of engagement. And next is the user session. Each one can have multiple user interactions corresponding to it. Last is the user ID, which can have multiple session IDs beneath it. Understanding this hierarchical chain is important for you as a data practitioner and for any AI trying to write a query so that joins and basic metrics like counts are properly executed. The next tool at your disposal is an entity relationship diagram. An entity relationship diagram, or ERD, shows how tables relate to one another and how they can be joined. The application I've been developing, Molecular Data, does this for you and automatically feeds the findings to the LLM context so it can be used for metric and analysis generation. For example, in this data set, there are multiple ID formats, and we want to convert the customer ID. Let's see if we can find one. Customer ID and work orders here to another ID format. So if we look at our data here, we can see that there's this table called customer ID formats, and this allows us to go from alternate ID to customer ID. So say I want to modify this customer ID here. We can see that there is a join, a May-to-May join between the alternate ID and the customer ID. So that makes that join very easy. It's important to note that not all joins will be clean. Some joins will appear to be solid on the surface, but when you dig into them, you'll find that they're actually more tenuous than you expected. For instance, there might be only a slight overlap between values in fields with the same name, but they have the same name. So if an AI sees that these two fields have the same name, but it isn't aware that there are only a few shared values, it'll try to make that join, which actually doesn't give you a lot of value. The system that I've developed here automatically susses those details out. In this case, there's a high level of overlap between these values, hence why it's a green dot connected or green line connecting them. And lastly, you can use the ERD to develop or to identify data gaps. Maybe you need to convert one value to another, but there is actually no mapping table. That mapping table needs to be admitted by an upstream source, or there are certain fields you need in order to make your data hierarchy more complete. The ERD gives you a high-level view to identify these problems and work with your upstream teams to solve them. Now that we've thoroughly explored our raw data and partnered with our data providers to make any necessary adjustments, we also need to monitor our data. There are a few tools in our toolbox to do this. The first tool is a data contract, which is essentially an agreement between our team, the data consumer, and the upstream data providers on what they'll be providing. Data contracts specify information such as the data schema, column formats, and types, the frequency of data updates, and how quickly issues will be resolved. There are robust ways to implement data contracts, but fundamentally, it boils down to an understanding between two teams and a sense of commitment from both to maintain that contract. The other tool you'll want to implement is a series of robust tests to measure the raw data coming into your warehouse. These tests should measure the consistency of the data. Is the data coming in using the same formats? And are the values fairly consistent? The volume of the data, rows, should show a table or a stable trend, When I say trend, I mean it should be moving in the same direction. So if your app is growing, you should see the number of rows in your engagement tables growing with it. It should also show the row counts should match with upstream systems. All tables should have unique keys to ensure row level uniqueness. Data should be fresh, consistent with the emission schedule from upstream systems. And schemas should remain consistent. Or if there is a change, the upstream team should notify you. So today we went over a lot in this video, but understanding your raw data is by far the most important step to ensuring your warehouse agents work correctly. As stated before, your raw data is the fundamental building block for everything else in your warehouse. So do everything you can to maintain its high quality. That's all from me today. If you found this video useful, please like and subscribe. I'll see you in the next one. Thank you.